Today we're going to be continuing our lesson from yesterday. We're going to be talking about how to compare data distributions. So really discussing the shapes that some of our data displays can make. If you take a look, we're talking about the dot plots that we went through yesterday. And we kind of can organize them into three categories, where the data ends up being fairly symmetrical. If something is symmetrical, it means that you can cut it directly down the middle and both sides appear to be exactly the same. So if you look at this middle one, this dot plot is definitely symmetrical. The one on the left has all the... Today we're going to be continuing yesterday's lesson, and the portion that we're going to focus on today is comparing the data distributions and looking at the shapes that these distributions can make sometimes. Yesterday we explored the dot plots, so today we're going to look at the shapes that those dot plots can end up in. If you look at the three examples, the one in the middle shows an example of a dot plot that's very symmetrical. Symmetrical means that you can divide it in the middle and you could fold it in half and the two halves would match exactly. So if you imagine taking this and folding it in half, all of the dot plot or frequency x's would match on both sides. Now, the one that's on this left-hand side, this is an example of when the data is skewed to the left. If you look, there's a lot more frequency on the right-hand side of the dot plot, and they call that being skewed to the left. The one over here is an example of being skewed to the right. There are a lot more frequencies on the left occurring, and that means that the data is skewed to the right. So if we look at a specific example, the data table shows the number of miles run by members of 2 track teams during one day. Make a dot plot and determine the type of distribution for each team, and then explain what the distribution means for each. So if you take a look at the information they're given us, it's the members of Team A, the members of Team B, the miles, and then the frequency of the members at that number of miles. They put together the dot plot for Team A. They put together the dot plot for Team B. And if you look, I would say that Team A appears to be fairly symmetrical. So it would be called a symmetric distribution. That means that the distances run are pretty evenly distributed around the mean. Okay? Now this one has a lot more data values to the right, which means that this would be considered skewed to the left. More than half of the team members ran a greater distance than what the actual mean was. Okay? Will the mean and the median in a symmetric distribution always be about equal? So like for Team A, if we calculated the mean and the median, what we would find is yes, that they do tend to be very similar. Now, when the data is skewed in one direction or the other, we're going to find that the median is going to be closer to where the values are clustered. So if more of these data values are clustered to the right, we're going to find that the median is further to the right than in a symmetrical distribution. Let's try another example. Let's say that we have Team C, and we're going to go ahead and make the dot plot ourselves. Now, remember your interval has to be consistent because we're working on a number line. If this is 2.5, 3.5, this would be 4.5, 5.5, 6.5. At 3 miles, there were 2 team members. At 3.5 miles, there were 2. At 4 miles, there were 3. At 4.5, there were 3. At 5, there were 3. 5.5, there were 2. And at 6, there were 2. Okay. Based on what I'm seeing, I would definitely call this distribution symmetric.